Hello, my name is Jana. This is our group project. The title for our group project is Cervical Cancer Risk Classification, and we're going to explain to you about our dataset. The dataset was collected at Hospital University de Caras in Caras, Venezuela. The dataset comprised demographic information, habits, and historic medical records of 858 patients. Several patients decided not to answer the questions because of privacy concern. This created some missing value in our dataset. I've been digging into this dataset and have been read several other analyses which formatted to diagnose cancer have been identified, which is biopsy, cellular encelment, which called as colposcopy, and cytology. For example, if biopsy positive and other result is negative, most probably she does not have cancer. So in this group project, we will predict if someone got cancer or not based on their information, habits, historic medical record. In this dataset, there is diagnosis variable which named as DX, and the DX variable will also seem like a good target since the final diagnosis, which is biopsy, cellular encelment, and cytology, is a product of test performance. The binary classification is used because there is only two possible, which is cancer positive or cancer negative. Most algorithms that can use for this binary classification included with logistic regression, k-nearest, decision tree, and naive bias. This is the package description. We use PyProt to visualize our data. Then we use Panda package to read CSV file. We use min-max scaler to scale the data. And then we use grid search CV, kfault, and cross-val score to hypertune and find our best parameter. In this case, metric used to evaluate the accuracy of the algorithm. Then for machine learning, we use logistic regression, decision tree, KNN, LDA, and SVM. Finally, the assemble algorithm that we use is AdaBoost, gradient boosting, random forest, extra tree, and voting classifier. Thank you. This is data pre-processing. The important part is pre-process CSV file and put the output into test tree CSV. And then initially, due to privacy concern, there is some missing data in dataset, so pre-processing is needed. In this case, we can use interpolation technique to estimate the missing value from other training sample in our data. The one most common interpolation technique is mean imputation, which we simply replace the missing value by mean value of entire feature column. A convenient way to achieve this is by using imputer class from skitlearn module as shown in the code. And then here is the original result before drop the column STD and AIDS. The column STD cervical condylomatous and STD8 is delayed because it does not have correlation with other column. This is the correlation matrix after those two columns have been removed. And the pre-processed data is then stored in new CSV file. This will avoid the pre-processing stage every time when we want to run machine learning, since the pre-processing stage is only done once. The attribute information will include with age, number of sexual partner, first sexual intercourse, number of pregnancy, which is shown in this graph. So in this graph, most of survey taker is the younger people, and then most of them have 2 or 3 partners. Some of them do have 4, 5, 7, and some of them do have 8, 9, 10 sexual partner. Most of them have their first sexual intercourse during their young adult age. And the most important column is diagnosis cancer, which means 840 do not have cancer and other 18 people do have cancer. This will make our dataset negative bias, means our prediction will likely to be false negative.
Hi, I'm Tan Chiang. I'm going to explain about how our set handle the data partitioning. First, our dataset contains 36 columns. We split the columns into features and target. Features is labeled as X, while target is labeled as Y. 35 columns were grouped as X as it contains the feature of this dataset, which is the factor that cause cancer. Some of these factors are age, smoke, and many more. The other one column was grouped as Y as it is the cancer diagnosis column, which indicates the patient has cancer or not. Both X and Y will be split into testing and training set. We use a testing size of 0.2, which means that 80% of the data will be used for training, while 20% will be used as testing. 80% of the data will go through training, and then the model performance will be measured with the 20% data. The performance measure here is the accuracy of the model. To implement this, first we set the maximum column of the dataset. Then X will get all the dataset data, except the cancer column with the drop function, while Y will get only the DX cancer data. Min-max scaler is used to normalize the data of X by scaling them into the range of 0 and 1. This is due to the feature in the dataset is in different unit, which means all the data inside the column has different scale. Different scale will cause us difficulty to the modeling. The min-max scale function will normalize the data by using the equation of Y equal to X minus minimum divided by maximum minus minimum. We take age as an example. Our data in the dataset is 28. The minimum age is to 18. The maximum age is 58. By using this min-max scaler, we will get a 0.25 data. Next, the data of X will go through polynomial transform. Polynomial feature is the addition of new feature where its value will calculate by squaring the values in X. This process is repeated for each input in the dataset, creating a transformed version of each data. Once the preprocessing of X has been completed, we use the train test split function to split the X and Y data into random, train, and test set. This function helps to minimize the chances of bias in evaluation and validation process. Figure in this slide shows how we insert the best parameters written by the training function into the model to retrain. Final evaluation will be done after all the model finish training. As we can see, cross-validation is used here. Cross-validation is used to estimate the skill of machine learning models. It was used in machine learning to compare and select a model. The method of cross-validation used here is K-cross-validation. The figure above shows the basic principle of K-cross-validation. Normal dataset splitting into test set and training set has some weakness, where the accuracy of the model might not be good, as the accuracy obtained for one test set can be very different with other test sets. By using a cross-validation, the data is divided into 4, and each 4 is used as testing set. In the figure above, the dataset is split into 5 rows. In the first iteration, the first 4 is used to test the model, and the rest are used to train the model. This process is repeated until all the 4s has been used as testing set. In our code, we use the default 10-4, which is a common number of 4. The K4 is done before fitting the model. For the model building process, we utilize library provided by scikit-learn. In this code, we use 5 algorithms to build the model. The 5 algorithms were k-label classifier, logistic regression, linear discriminant analysis, decision tree classifier, and support vector clustering. This 5 algorithm is implemented using the scikit-learn library by importing them into the code. Some parameters had to be inserted. These parameters are written after the heterogeneous process is done towards the SVM and KNN algorithm, which give the parameter for the algorithm to produce an output with the highest accuracy. So total algorithm used were 7, 5 originally, non-tuned, and 2 is hyper-tuned.
Hello, my name is Muhammad Zainuddin and I will be talking about evaluation and performance metrics. There is 4 performance metrics that we use, which is accuracy, time taken, consistency, and confusion matrix. Accuracy decides whether the result is accurate or not. Time taken is the time consumed by the algorithm to predict the data. Consistency is the consistency level of data, whether it will get the same result after multiple prediction. And confusion matrix is to display the false negative or the false positive. Then this is the evaluation method for each matrix. There is accuracy using accuracy score. Time taken will be using time differences. Consistency will be using the mean and standard deviation. Confusion matrix will be using confusion matrix functions. Then this is our result for SVM algorithm. The mean is 0.9767, but for the hyper parameter tune one, it is 99.57. The deviation for non-tune is 0.16 and the tune one is 0.06. And for the tune one, it takes less time than the non-tune one. Then the time taken for LDA algorithm is 0.77 seconds and the time taken for CAD algorithm is 0.02. So the best algorithm is the algorithm that use less time, highest accuracy, lowest deviation, and a good mean output. This is the algorithm comparison for all of the individual machine learning algorithm that we use. For hypertune SVM, the mean is almost 1.0 and it has a standard deviation until here. Then for the non-tune SVM, it has this is the median, which is 0.97 something, and this is the standard deviation. For the non-tune algorithm, it has bigger standard deviation compared to the tune one. For KNN, it has lower mean and higher standard deviation compared to the tune one. So tuning has improved the performance of each algorithm. The worst algorithm for this project is NDA, which has 0.92 median and has big standard deviation compared to others. This is the ensemble algorithm comparison for ADA boost, gradient boost, and ET. It has median of 1 mean. This means most of the time it will have 100% accuracy, almost 100% accuracy, but it still has a standard deviation until almost 0.985. For this RF random forest, it has a median of 0.994, which means most of the time when we predict using RF, we will not get 100% accuracy. And the lowest median accuracy is at voting classifier. This is because only 2 of our original algorithm is getting the accurate result and the other is getting not accurate result. This will drop the average accuracy of voting classifier. On the next slide, I will demo our project. This is the original dataset where there is missing value, and after pre-processing, this is our dataset where the missing value is replaced with the mean value. This is our program. First, it import all of the library, and then it get the dataset, and then after printing the dataset details, it will show the histogram for our data. This is our data visualization. It shows the age, the quantity of the data, where there is much people without cancer and there is a few people with cancer. This is our correlation diagram. It is shown by using this comment color bar, make show, and then our program will start running. Then it will first, this is our function. First, our program will get the tune KNN parameter and then the tune SVM parameter. Then we will put all of our algorithm in array, and then we will loop and test for each algorithm, and then it will print this result where it shows every algorithm details. This is the graph that explained earlier, and then it will put all of the ensemble algorithm into an array, and it will loop through all of the array. After that, it will print the detail for each algorithm. In this case, AdaBoost classifier have 100% accuracy with a mean of 0.99 and it take 1.03 seconds. It get 172 correctly negative and 2 correctly positive. It get 0 error. That's all for our program demo. This is the function that I use to generalize our project, to simplify our code, to make it shorter. Thank you for paying attention. That's all from us. Thank you.